Let's see what kind of important information we can get from the periodic table. So today we're going to see how, on this side, information about the specific elements on the periodic table can give us amazing information about specific elements. So if I go and I show you this one right here, so we will be working today with 3 elements. Here's the lithium. So as you can see here, there's a number, which is the atomic number. We also have at the bottom the atomic mass. These are the 2 numbers we're going to be working with to find key information about elements. Perfect. So let's double check. So first of all, when you think of an element on the periodic table, we have the basic information. We have the atomic number, atomic symbol, the name of the element, and the atomic mass. This is all we need to find key information. And that key information is the following. We're looking for the number of protons, number of electrons. We also look at the number of neutrons within the element that we are using. So let's see. So first of all, if we are looking for the number of protons, it is easy to find because the number of protons is always how many positive charges there are in the nucleus, and it is always the atomic number. So if we're looking for the number of protons in the element or the atom, we have 3 protons. It's easy to find because it's the atomic number. When we start in chemistry, we always work with neutral atoms. So let's see, neutral atoms. So if we're looking for neutral atoms, that means that the number of protons and the number of electrons are exactly the same. If we have here 3 protons, we have 3 electrons. Now the next step needs a little bit more work. We are looking for the number of neutrons in the atom. The number of neutrons here identify the different types of isotopes that are available for specific elements. I'm going to talk about isotope in about 5 minutes. If I'm looking for the number of neutron in a lithium atom, we're going to go with the average, we're going to use the average atomic mass of this element. So here, if I have lithium with an atomic number of 3, there you go, and the atomic mass of 6.94, first thing we're going to do is look at the mass number. The mass number is always here in grade 9. We are looking for we're going to round this number to the closest integer or the closest whole number. Because we have 6.94, the mass number here will be 7. Now this will be useful because the number of neutrons when we think of an atom is always the mass number. And we take away the atomic number or the number of protons, and that gives us 4 neutrons. So if you think of lithium atom, a lithium atom would have always 3 positive protons, always 3 negative electrons if we're dealing with a neutral atom. So here there's no charge on that. We'll talk about charged atom in a future video. And then we have the number of neutrons that here we have 4. This is the basic information because this allows us to identify the element, also see how it reacts with its environment, but also the number of neutrons would tell us some physical properties such as the density of a group of those elements. So this is the first element we're doing right now. The second one we'll do will be, let's see if we can do oxygen. I think oxygen is a great idea. The second element we're going to do today is oxygen. If you go on the periodic table, you will notice that the oxygen has an atomic number of 8, has here a symbol of O, a name, which is oxygen, and an atomic mass, which is 15.999. Now, the precision of these atomic mass differ depending on how accurate your periodic table is. So let's see if I can use this information to find how many protons there are in the nucleus, how many electrons around the nucleus, and how many neutrons there are within the atom. So let's see. We have this one here. The number of proton is always the atomic number. So if you look at the information here, the atomic number is 8. because we're starting in chemistry, we always have neutral matter because the first thing that matter wants to do is to be neutral. That means that if we have 8 protons, we have 8 electrons as well. Now, if I'm looking for the mass number, let's see what I need to do. I need to take the atomic mass. In order to find the mass number, I have to take this atomic mass, round it to the closest whole number or integer, and we have here 16. So here we have a mass number of 16. How do I find the number of neutrons in the nucleus? I'm going to look at the mass number. I'm going to take away how many protons I have. So that means that here I have 8 neutrons. And that's important because in the next video, I'm going to be working with how to create Bohr-Rutherford diagrams to have a good visualization of what an atom is structured. We need this information. Number of positive charges, proton, number of negative charges, electrons, and number of neutrons in the nucleus. So that's our second example. Let's see if we can do the third example, and we're going to choose chlorine today. My third example is chlorine like this. So if we go on the periodic table, we see that chlorine is located right here, right in this place right here. So this is a halogen. And if you look, so chlorine, if you look at the information, we have an atomic number of 17 and an atomic mass of 35.45. So that one is tricky because how will we round that number? So let's have a look. So if I'm looking for how many protons, the atomic number is 17. That's the first one. Now, if you're looking for the number of electrons, knowing that we're working with neutral atoms right now, we're going to have the same number of electrons than protons. And that gives us 17 electrons as well. Now, the next one will be, how can we find how many neutrons there are? So here, to find the mass number, we have to look at the atomic mass. Here we have 35.45. So it's very close to 35.5 here. So here we're going to see how some people may look at it differently. If we look at the mass number and we round this number, rounding this number will be 35. Like this. So if we have a mass number of 35, and I'm looking for how many neutrons we have here, we take the mass number minus the atomic number, which is 17. That means that we have 18 neutrons. But what is interesting is that here we have 35.45. So that means some people would say, well, why can't I use 36 as a mass number? Well, if you use 36, like this, 36. So 36 minus 17, because the atomic number never changes for a given element. We have here 19 neutrons if we're using an atomic mass, if we're using a mass number of 36. So this brings us to a concept that we call isotopes. Isotopes. Okay. So when you have an element and you have several isotopes of the same type of elements, so here's an example. We are using a situation where we have the atomic number, which is always 17 for the chlorine. That never changes. However, within the nucleus, some of the atoms of chlorine have 18 neutrons and some have 19 neutrons. So when you have an atomic mass, and sometimes it's not a perfect number, people ask, how come that is? It's because the atomic mass of an element is the average mass of the different isotopes or the different percentage of isotopes we have for a certain element. So here, if I decided that, for example, let's take another color. If I had that half of the atoms were mass number of 35 and half of them had here an atomic mass, a number mass of 36. If you were to do the average of both of them, you end up with 35.5 or close to this. So that's a simple explanation of first what is an isotope, and also how come we have an atomic mass which is not a perfect number. So if I go to the periodic table, so if I take, for example, nitrogen, so nitrogen here has an atomic mass of 14.007. So most of the atoms of nitrogen are close to have 7 neutrons. If we go to, for example, copper here, copper is 63.4546. So here you could see that, you could say, well, maybe half of them have, so for this one here, so 30, so that's 30, some of them have 34, other people have 35 neutrons, depending on how it goes. And here the number is very close to 63.5. So that means if there were only 2 isotopes, there'll be half of them for one with a certain amount of neutrons and the other half with the other. But if you do some research, you will notice that oxygen, for example, have 2 or 3, even more than isotopes. I think chlorine may have 7 or 8 different ones. Now, there's one that is the most of it, and then all the other isotopes seems to be a bit less in concentration or in amount. So this atomic mass is the mass of proportional quantity of different isotopes of that same element. Keeping in mind that we know it's always the same elements because the atomic number is always the same. So hopefully that is good. So we have chlorine. Excellent. If it happens you have questions or clarification questions related to how we get information from the periodic table, please do not hesitate to put your questions in the comments below, or ask any questions that you thought of as you were seeing the video. Because keep in mind that every time you have a good question and you have a good answer to your good question, it opens up room for new amazing questions, and that's how you expand your learning. In the meantime, I'm going to put here a link to another science video, and I'll see you there.